I am Dr. Nilesh S. Dumore, co-coordinator of FDP and head of the Chemical Department, SN Patel Institute of Technology and Research Center, Umrakh, Baduly. I would like to warmly welcome to our estimated expert speakers, Mr. Shankar Karhale, for today's faculty development program sessions. We are truly honored to have such distinguished professions in our midst, bring their extensive experts in covering safety, health, environment, and sustainable and manufacturing to share with us. So, Mr. Shankar Karhale is Vice President and Corporate Environmental Sustainable Head at the RT Industries. He has 13-year experience in chemical industries, CTPS and common TDFT facilities covering the safety, health, environment, sustainable manufacturing. And his last organization was the UPL Limited, Private Limited and Group Companies. As of the today, he is working with RT Industries as a head corporate environmental and sustainable since from the April 2029, 2019. He is supporting the 16 manufacturing units and 14 green field projects. So importantly, he is playing a dual experience at SHE and sustainable corporate and manufacturing. He has made the many implementations in the field of the environment, energy and operations for the water conservations, water reductions, emission reductions, hazardous and other waste reductions at the sources, and waste conversion into the valuable product. So waste to the co-processing and the cement industries, energy conversion, green belt development, GHG emissions assessment and reductions. And he is also the team member for the acquiring new assets and plants. And he was the hazardous waste innocence of the Gujarat waste in the year of 2005 along with the GCPC. And he has been nominated for the Platinum Workshop on the Green Productivity in Kuala Lumpur, Malaysia for 1 month by the Indian government and APO Japan. And he is the member of the various associations like the ICC, FICCI, Ankleshwar Industrial Association and GCCI. So it's all about our introductions of our experts, Shankar Karhale sir. So now we will enjoy the healthy sessions with the Mr. Karhale Shankar sir, Shankar Karhale sir. So I request to Shankar sir, please continue your sessions, please sir.
Yeah. Thank you for a nice introduction and good evening all. So we'll take you for a one and
Now it's visible sir to you.
yes. Yes.
Okay.
Friends, sorry for inconvenience. Yeah, we'll restart again. Yeah. Yeah, next. Okay. So I am taking case study of the particular question. My voice is clear?
Yes sir, voice is clear. It might be your internet is slow, so you can
I will
switch off
close
your
my
camera
camera.
also.
Yeah.
Then voice will be clear.
Now okay.
Now it's okay. Yeah, it's okay.
So I'm taking a case study for pesticide sectors. In pesticide sectors also, if you see this chemical reactions like normal chemical reaction in other pharma, dyes and dyes intermediate specialty chemicals, all these things happen in pesticide sector also. Only there is a last reaction. There is a formation of the pesticides, yeah, insecticide, herbicide, and all these things. In chemical process involved batch, continuous, semi-continuous processes like distillation, extraction, crystallization, filtration, and evaporation. So same in pesticide sector also. In general chemical reactions, you have already seen A plus B is equal to C plus D. Add in pesticide sector last reaction D plus E is equal to F. So that is a F is a pesticide. Otherwise, there is a normal reaction same as other chemical industries. Here C may be the byproducts. F is a pesticide. D is a intermediate like pharma, specialty chemical and all this. Yeah, next. So pesticide manufacturing is the fourth largest producer agrochemical India after US, Japan, and China. Consumption of pesticide in India is a 600 milligram per hectare. Consumption of pesticide in other developed countries is 3,000. This is about 5 times more than Indian consumption. So there is a major acts applicable to pesticide sector is the Insecticide Act 1968. We are given link also here. So uses of pesticide is a agriculture, public health, other than agriculture like uh, uh, wood and preservation storages, domestic, personal, and building construction also many times. So these are use of our uses of pesticides. Yeah, next. So type of pesticide is a very important part because depend on the types, the utilization is a separated. If I see this herbicide is a part of pesticide, but herbicide is a different insecticide. So this kill the chemical this kill the plants, either prevent to control them. Modern synthetic herbicides are often used to control invasive plants. So grass like this for destruction of the grass and other uh, invasive plants destruction. Fungicide, chemical compound that prevent or control the plant disease contact. Fungicide from a proactive barrier on the outside of the plant to prevent disease from the penetrating the tissues. Rodenticides used to kill rodent. Insecticide used to control or kill the insects. Carbamates, a group of insecticide that work by including the enzymes that important for the nervous system function of the these leads to paralysis and death of the insects. Organochlorine insecticide, organic compounds that are attached to the 5 or more chlorine atoms. They were one of the first category of the pesticide ever the synthesized. Organophosphate insecticide, ester of the phosphonic acid that are the commonly used as an insecticide to control the pest in agriculture, building, and the homes. Biopesticides are the newly introduced by government. So pesticides based on the natural product or microorganism that control pest using the non-toxic mechanism. Biopesticides are used to protect crop from the pest, insect, fungi, bacterial, and viral disease. Yeah, next. Yeah, next. So almost all chemical industries, chemical sectors are almost water and wastewater management are same. Maybe slightly there is a difference. Otherwise, there is a commonly chemical industries, pesticide sector also need. Only in pesticide sector, only different is a you have to destruct toxicity here before sending to the effluent treatment plants. Yeah, landfilling or incineration plant. That is only one criteria in pesticide sector. Otherwise, the normal wastewater generation and treatment methodology is same like other sectors. So water consumption in pesticide mostly cooling tower, boiler, and domestic process like other chemical industries. Water sources in Gujarat from GIDC. So if you are taking water from GIDC, then GIDC permission required. Borewell, then CGW permissions are required. Wastewater generated from processes, industrial means cooling tower, boiler, blow down like this, and sewage and generated wastewater which cannot be used back into the processes, they are discharged without treatment. This is like definition of the wastewater. This wastewater gets treated in dedicated wastewater treatment plant. So approach towards the treatment and disposal of wastewater. So first is a non-ZLD system. So need primary, secondary, and tertiary treatment. Disposal may be depend on the location of the industry located. So most of the Gujarat, uh, almost all industries should have common facility, common treatment plant. Yeah, some place there may not be available. Then they have to discharge the river, sea, marine norms may be applicable, or surface land. So depend on your discharge, that norms will be decided by CPCB as well as State Pollution Control Board. So if you are discharging to CETB, so CETB inlet norms will be the applicable. If you are discharging to river, then your norms will COD norms will be 250. If you are discharging to deep sea marine norms, will be applicable like 500, 700 COD. If you are using on the land, then maybe COD is below 100. Second approach is a ZLD system. Here needs something additional equipment like RO, multiple effective operator, and ATFD, as well as STP also required for sewage treatment plant. So this much required to you for additional requirement for ZLD. Partially ZLD system and partially discharge. This is also required ROMA and ATV. Only here some partially treated water PPT is not visible like this. There is a message. My voice is clear, na?
Voice is clear, no issue. PPT is also visible,
I'm,
but it's
I'm visible. For me, visible, but someone message there.
yeah, it's maybe due to the internet connection is slow, sir. That's why. Sure.
Evening time. Okay, no issue. But appreciation to all participation. They gathered at evening time also. So,
Yes, yes.
yeah, next. So why wastewater treatment is important? Because if you're not treat your wastewater, then there may be impact on the environment as well as your health. To meet discharge norms of CETB, because before discharging to CETB, you need some treatment. Then only you can achieve the CETB inlet norm. Like deep sea discharge norm also, there is a different norm. So for achieve that norms, you have to treat your effluent. Even though water recycling, even though generally needs some treatment, then only possible in chemical industry to recycle your effluent into processes as well as cooling towers. Hence, before treatment, your segregation part is a very, very important in chemical industry. If you are not properly segregate, then your effluent treatment plant will be the discarded, means not running properly. A lot of issues will be there. So always see in any chemical plant, even the pesticide plant, pharma, all sector. So segregation of effluent is a very, very basic requirement and a very, very important part. Yeah, next. So generally, in a chemical industry, there is a segregation like process effluent, industrial like utility effluent coming from the boiler, cooling towers like, and washing, cleaning, and scrubbing, uh, and domestic water last. So this type of effluent segregation happen in chemical industry. Yeah, next. So by experience, I have given here how to segregate effluent in chemical industry. This is on by experience only. This may not be written some books also, but by experience, I have segregated effluent and we got result also for particularly this thing. So if you see this type of effluent, so low COD and low TDS effluent. Low COD, low TDS means below 5,000 COD and TDS 10,000. If BOD is more than 30%, you can take directly into the biological treatment. This is a thumb rule or by experience we have written here. If BOD is less than 30% of COD, maybe there is a slightly refractory COD there. So need pre-treatment like chlorination, ozonation, penton H2O2 and followed by biological treatment. Some effluent having nitrogen like ammonical nitrogen, but low COD, low TDS effluent. Then pre-treatment required for ammonia treatment because ammonia is a toxic to the biological treatment. So you have to reduce your biological before biological treatment ammonical nitrogen below 50. Then only biological treatment will be run efficiently. So maybe pre-treatment like H2O2, stripping, MAP system, all these things are required to stabilize ammonia. High COD and low TDS, second type of. So if COD is due to the VOC, VOC is a volatile organic compound, low boiler point. So stripping and followed by biological. After stripping, that volatile organic compound is separated from that effluent, and your COD will be the low COD and low TDS effluent that can be treated in the biological treatment. If BOD is low, having toxicity, then required chemical treatment like for increase your BOD COD ratio may be required ozonation, penton, and you have to improve the BOD COD ratio like 30% of the COD. Then only followed by biological treatment. Third is a low COD, high TDS effluent. TDS is about 4%, means 40,000 milligram per liter. If COD is not due to the solvent, you can take directly to membrane separation or plus ME followed by the biological treatment for condensate if required. Many times you are getting condensate clear, there is no impurity or no COD, then that can be utilized into the cooling tower directly. Low COD, high TDS, above 4%. If COD is due to the compound having the high boiling point, then you can go directly into the multiple effective evaporator, or right now there is a advanced technology, MVR also, and condensate, because due to the high boiler, condensate is a clear. That time you can utilize into the cooling tower. If COD is due to the compound having low boiling points, then need ME, but due to the volatile organic compound, your condensate is not clear. Lot of impurities may be there due to the VOC. That can be required biological treatment again. Yeah, next. Then high COD, high TDS. If COD is due to the compound having low, stripper required followed by ME. Or sometime incineration, depend on the toxicity and all this. High COD, low TDS with high CV value. If CV is above 2500 and chloride is below 4%, then co-processing. Otherwise, that can be goes to the incineration if toxicity also there. Co-processing means you are sending your residue to the cement industries directly. So cement industry utilized as a fuel replaced by coal. So co-processing is a very good phenomena motivated by in most of the Ministry of Environment and Forest, CPCB, as well as State Pollution Control Board like GPCB. So here is a very important, your carbon footprint is a reduction, your fuel consumption is a reduction, and very favorable condition to destruct your residue, because whenever your combustion now there is a 3 T is a very important: time, temperature, and turbulence. So I will compare to incineration and particularly cement industry. So incinerator plant have the time is a 2 second resident time, 2 to 3 seconds, and co-processing cement industry rotary clean having time is about 10 to 20 seconds. So there is a more resident times there. Temperature 11-15 in incineration plant and co-processing is about 1800 to 2000 degrees centigrade. In incinerator plant, many times there is a stationary chamber, so turbulence may be less. But if you see the cement industry, there is a rotary kiln always, so there is a lot of turbulence, and hence the combustion at cement industries is a very good. Efficiency is a very good. That why mm, Indian government as well as GPCB is motivating for co-processing to cement industries. And now adding incineration because lot of energy required to you run your incineration plant. Then if you are utility effluent like a cooling tower blowdown, boiler blowdown, so collect and you can directly taken into the ETP or some pre-treatment required and you can discharge to if there is a marine or CETPs depending on your location. Sewage effluent you can take into the STP and STP treated water you can utilize into the green belt development or cooling tower after chlorination because there is a slightly bacterial. So there may be algae generation if you are not fluorinated that compound. Yeah. Next. So we see what is the effluent treatment plant. So effluent treatment plant, we have already segregated our water for biological treatment. Nothing is a biological treatment ETB plant. Is depend on the your quantity, quality of the effluent. You can select your types of ETP, activated sludge process, MBBR, MBR, depend on your trial run or your treatability study. You can select your technology. Correct. So here is a primary treatment, biological secondary treatment, and tertiary treatment here. If you see this primary treatment, this is both physical units operation and chemical unit operations. In a preliminary treatment, means you can do as a physical separation as well as sometimes required chemicals like chlorination, ozonation, penton, all these things are chemicals required. In primary treatment, here also both physical as well as chemical because you are removing gases by physical methodology by separation, acetylene, and chemical reaction like coagulation and flocculation. Lime we are adding, there is a lot of acidity, so there is a chemical reaction is happening here. Biological treatment is a there is a two types aerobic process where oxygen is involved, air is involved, and type of aerobic system like activated sludge process, MBR, MBBR, and SBR, sequential bioreactors. Anaerobic process, there is options of air and oxygen. Is mostly utilized wherever there is a COD BOD ratio is about above 70, then there is a possible of anaerobic process. But chemical industry, mostly 30% of BOD, like pharma, pesticide, dyes and dye, specialty chemical. But food and alcoholic industries have higher COD BOD ratio, like 70-80%. Tertiary treatment, both physical unit operation, chemical unit operation. Physical like ROs, sandbelt filter, or carbon towers. Chemical like chlorination or odor remove, color remove, like this utilization by industry. Whenever you are at a greenfield project and you want to establish ETB plant, so R&D level product manufacturing and effluent generation is a very important. You have to take a lab trial, pilot trial for your effluent and select technology, select capacity for particularly generated effluent, resident time, flow, that is are very important during the design stage. These all parameter PS, TDS, ammonical nitrogen, SS, DO, all these thing parameters evaluation are very important at pilot trial as well as lab trial. Once ETB started in under operation, then you have to monitor performance monitoring depend on KL per hour, KL per day, qualitative and quantitative. quantitative feed per day and per hour. Qualitative like COD, BOD, ammonical nitrogen, SS, kg load, and all other parameters are very, very important. If you have pesticides, then pesticide also at inlet level as well as outlet level you have to monitor. And metals also, that is also applicable to all industry. Yeah, next. So this is a pictorial part for particularly biological treatment above photos, uh, arrows, then activated carbon and multiple effective operator here. Yeah, next. So this is a sewage treatment plant. So this is also very, very important equipment nowadays to industry, because there is a one notification to chemical industries. Whenever there is a manpower is a 200 above in your industry, as well as if your discharge, if your generation of the sewage 20 kl above per day, then you have to install STP. So this is nothing as a this activated sludge process or MBR, MBBR type of PTB. Same phenomena here. Only here is a slightly BOD COD ratio is slightly higher here, and there is a compact equipment here STP. Here also mostly primary, secondary, and tertiary utilized. So same thing operation phenomena for particularly ETB. Small, maybe 50%, yeah, 30% generation of the your industrial effluent. Yeah, next. So I have given here types of ETP and the treatment methodology and equipment here. So if you see this, first is activated sludge process. So primary treatment is a common for all type of ETP. Only biological treatment is slightly changing. So activated sludge process is a old type of technology. So it requires slightly more area footprint is compared to the MBR and MBBR type of or SBR type of technology. Anoxic tank there, activated sludge aeration tank is there, a clarifier and recirculation and wasting also there. And tertiary treatment is a common for all treatment facility. MBBR also one of the good type of compact type for aeration tank. Other area footprint will be the same. Only the aeration tank is a compact because there is a media you are utilizing there, and so that there is a area increase into the tank and reduce the your volume and area for particularly aeration tank. Other systems are the same. Yeah, next. MBR is a slightly, again, there is advanced technology, membrane bioreactors, primary and tertiary treatment is the same. Only if you see here, so there is no clarifier here. So this MBR utilized as a clarifier principle. So here is a slightly suspended salt is a very less, like in activated sludge process about you are getting after clarifier is 80 to 100. Here is at 20 to 30 you will get suspended solid. So clear water you are getting here. And one more benefit here, a normal activated sludge process, you can your biomass may be 3 to 4,000 milligram per liter. Here you can accumulate about 10,000 to 20,000. So that benefit also you are getting in MBR technology. Only slightly skilled member required to handle that MBR only part, that part. So otherwise this is a very good technology. Yeah, next. So zero liquid discharge. Many times you get question, what is a really ZLD for company? So near your total effluent generated, you should treat and recycle back into the process in our cooling tower, as well as domestic water also you have to treat and recycle into the your processes. Only generated sludge waste, landfilling waste, you have to send to the TSDM facility. That is called ZLD units. So ZLD is always closed loop, mostly required pre-treatment, then effluent treatment plant, reverse osmosis, that is RO, then required evaporation system like a multiple effect evaporator or MVR and STP plant. In MVR, again there is a required ATFD also, yeah, crystallizer, yeah, centrifuge to solidify your generated concentrated MVR and ME product. So that much equipment required to ZLD. Yeah, next. Already discussed on the pre-treatment. After segregation of effluent, many effluent having high CODs, yeah, high phenol, high ammonia. So many times required pre-treatment before sending to the particular biological treatment, yeah, ETP plant. So if you see these advanced technologies like photochemical oxidation, catalytic wet air oxidation, ozonation, electrochemical oxidation, and phenton oxidation. Phenton process is the most popular because this is a easily oxidized, highly oxidizing agent, H2O2 and ferrous sulfate. Yeah, we'll see this in detail. Yeah, next. Sir. So phenton is nothing else. This is oxidation, and we are generating OH radicals there by using H2O2 and ferrous sulfate. This reaction happen on 3 pH. So if your pH is above 7 like this, so you have to acidify and reach 3 pH. Then only this reaction is happen along with ferrous sulfate. So this is a research by Fenton scientists. That's why there is a Fenton name is there. Or required a lot of chemicals. So this is a costly in industrial area about maybe 4 rupees to 8 rupees cost per liter to Fenton treatment. If your COD is like 40,000, 50,000, and if you want to brought down to 5,000 in biological treatment followed by, then maybe 6 to 7 rupees, yeah, 4 rupees, depend on the slightly characteristic of that particular compound. So here also, if you want to establish your penton treatment, then trial is a lab trial and pilot trial is a very, very important. This can be happen batch as well as continuous mode. So batch time also very, very important during design time because depend on your production, you have to decide batch time and batch volume also. Dosing system also very, very important. What type of dosing we are doing per hour per ferrous sulfate, what flow is there. Temperature control system because this is a exothermic reaction here happen. So need cooling and all these things, proper cooling design. Then samplings also very, very important. You have to check parameter like COD, BOD, ammonical nitrogen, phenols. Depend on your character, what type of you want to reduction. That parameter you have to analyze and monitor. Here also you can monitor your performance qualitative and quantitative. Yeah, next. Reverse osmosis. This is also one separation methodology. Mostly reject we are getting through a high TDS. So this is one of the separation methodology by depend on the molecular size. Correct. So here is a pressure. With a higher pressure, there may be in reject high TDS. That's why there is a higher reject. So a lot of membrane companies in the market right now here, but very important here is a pre-treatment. Pre-treatment for the particularly silica hardness, turbidity. Pre-chlorine also very important here. Before feeding, you have to check your chlorine should be the nil. There is no solvent. Hardness should be very low. Silica should be very low. Then only your performance will be the improve the particularly RO performance, like qualitative as well as quantitative. Qualitative means your TDS value you are measuring, your COD also measuring. So if your TDS is higher than 150, you may not be recycled directly into the your processor or cooling towers. So always there is a quality of the TDS is a very important in our permeate. And quantitative your recovery need, if your TDS is a 5,000, so first stage required 75 and second stage total recovery may be the 90-95%. So that's why qualitative and quantitative uh, performance monitoring is a very important. So there is a life of the particular membrane. So for improve the life of membrane, pre-treatment and solvent free and chlorine free is a very important to feed your effluent. Yeah, next. So multiple effect evaporator again, mostly high TDS effluent feeding to the multiple effect evaporator. Yeah, RO reject feeding to the particularly multiple evaporator. Nothing else. Previously in old is there is a single stage evaporator required 1 kg evaporation required effluent required 1 kg steam. But here is a multiple stages like 3 stage, 4 stage calendar year and condensation. So here is a required 1/3, 1/4 the steam required here, because here is a steam economy increase by addition of the equipment here like calendar year and condensation. So here is a 0.25 to zero point 0.4 steam economy. Here steam required for 1 kg, effluent required for evaporation required maybe 0.25 or zero point 0.4 kg steam. So very good economy. That's why right now most of the industry are utilizing multiple effective operate. One more advanced technology is MVR, mechanical vapor air compression. So that also equipment is very good compared to the ME. Only power requirement is there. Steam is a negligible amount required for starting to MVR. Here also treatability study is a very important, okay, because pre-treatment also very important in this area. So for that pre-treatment for silica hardness, turbidity, all these things, chlorine organic, all these things you have to require pre-treatment and monitoring of the parameters also. Here also performance qualitative and quantitative performance required. So qualitative means your condensate should be properly uh, chemical free. Then you can recycle back into the your processes, cooling tower. Otherwise need again treatment for that particularly. So again there is a cost addition. Okay? Yeah, next. So ATFD nothing concentrated effluent generated from evaporation system like MEA, MVR, a single stage feed to here. This is a single stage. Again, you can tell evaporator, but here is a thin film. So this is properly evaporating, and you will get below 10% moisture here. Slightly costly equipment due to the MOC and all these things. Yeah, but here steam economy is a 1 kg effluent required, 1 kg steam here, not multiple effective operator like. Yeah, next. Next. So uh, I have taken here one pesticide industry's norms particularly. If you see this is other parameters are the almost same. That is depend on the your location where we are discharging. Only addition if you see this bioassay test. Bioassay test means you are treated effluent, 100% treated effluent, 90% of survival of the fish in 96 hours. They are taking during the trials, bioassay test trials, 6 fish, then 100% effluent, and they are checking for 96 hours. If you have 90% survival of the 6 fish, then there is a bioassay test is okay. And other some specific pesticides they have given limit. So that much pesticide you have to check in your treated effluent, then only you can discharge to depend on your location like deep sea or CETP like this. Yeah, next one. So air pollution control measure will see second part. Like first part is a water and effluent. Second part is a air pollution control measures. Yeah, to chemical industry as well as pesticide industry. Yeah, next. So if you see this mostly in chemical industry or pesticide industry, three type of emissions. One is a flue gas emission, wherever you are using fuels like boiler, power plant, thermic fluidifiers, yeah, furnace, DG sets, all these things emit flue gas. Process emission depend on your chemical reaction and chemicals. That emission will happen mostly generally HCl, ammonia, chlorine, SO2, NOx, H2S. Correct. Depend on your chemicals and chemical reaction. Fugitive emissions due to the equipment leakages, flange, valve, some spillage, leakage, overflows. That fugitive emission happen. Vents not connected to the particular scrubber. All is a fugitive emission sources. Yeah, next. So source and control. We have already discussed on this. This is a we have in pictorial form in flow diagram I have written. So PM is a particulate matter, SOx sulfur dioxide, NOx is a nitrous oxide, FGD is a flue gas desulfonization. This is required for SO2 or reductions in the boiler. If you are utilizing local coal or petcock like this, then there is a sulfur is a higher in that. Then you cannot be controlled by addition of the dry scrubber lime with the lime and coal combination. That time required FGD, flue gas desulfurization. That is a costly part and generated lot of effluent and not successful study also to operate that. So like this, there is a two-part process part as well as flue gas part. So in flue gas emission control for PM is a ESP, cyclone and back filters. For SOx, FGD, dry scrubber, lime injection along with code, NOx low, NOx burner systems are required. And here in a process, depend on the process emission. There is you have to choose media, water, alkali, acidic, all depend on your what type of emission. We'll see in the later slide. Yeah, next. Next, sir. So I have given some by experience some pollutant and scrubbing media like PM, water, cyclone, separator, back filter, and ESP is there. For SOx, wet scrubber like alkali, caustic, dry scrubber along with lime, sodium hydroxide, NaOH that is alkali only. Like this, there is a calcium carbonate also many times, calcium oxide, lime also many times. NOx also almost same scrubbers required. VOC is carbon and thermal destruction. For a higher quantity VOC required thermal destruction like furnace and all this thing. So that is also one requirement. Like incineration is a thermal extraction for VOC. You can connect your VOC to your incinerator plant, so thermally disturb. Ethyl mercaptan, thermal destruction also possible. NaOCl solution can be destruct the ethyl mercaptan. Ammonia, water, and acidic. Water is a better because you are recovering ammonia and utilizing to somewhere. Like HCl also, chlorine and HCl also water. If you are really utilize water, then you can get concentrated HCl up to 30%, and that can be utilized into the as a byproduct. Br, bromine required alkali and caustic. H2S alkali scrubber. HF NaOH alkali scrubber required. So like this, you can select your the scrubbing media, and but operational control, design part efficiency, scrubber media circulation and distribution is a very important. Inlet temperature also, along with your gas impact on the your efficiency. So always see the your preventive maintenance, reactive maintenance of the your scrubber and scrubber medias and all these things. Yeah, next. Control of particulate matter. Mostly this is in a solid product as well as even though coal based solid waste fuel, particularly generate particulate matter. You need a cyclone separator, multiple cyclone separators or bag filter. Or if you want to result very like 20, 30, 40 ppm, then ESP also you can utilize. Yeah, next. Cyclone separator also to control PM due to the centrifugal force that is a due and gravity of that particular center of gravity, your particulate matter is goes down and separate in the cyclone separator. So this is also one particulate matter removal equipment. Yeah, next. Backfilter also one of the equipment to control PM. This also uh, compared to cyclone separator efficiencies are very high, lower than ESP. But this is also utilization in product as well as sometimes in incineration, sometimes even backfilter in your boilers and all these things. So here is a very important is your air, vibrating air also utilizing vibrate the your bags and cleaning internally. But again, you have to clean periodically, and reactive maintenance also very important. Many times that bag burn or tear the bag, so you have to see the performance always monitor the performance inlet and outlet is a very important here. Yeah, next. Next, sir. ESP is a very good equipment, slightly capital investment higher than the Cyclone as well as bag filter, but here required power also, particularly to generate ions. But result are very good. Maybe 20, 30 ppm we will get a particulate matter. So this is also utilized for product as well as in incineration plant as well as in boilers wherever there is a solid fuel or solid inputs. Yeah, next. Next, sir. So in process also we already discussed this observer. Many times there is a dry as well as wet. In wet there is a pack type column, and there is a depend on the design, there is a packaging material, interlock saddle packaging. There are different type of plate type tray, yeah, venturi scrubber there. And dry there is a sometimes carbons, sometimes lime, sometimes uh, limestone utilizing dry scrubbers. and absorb the your generated emission from processes. Yeah, next. Next, sir. This is a packed bed. We already discussed. Here is a distribution phenomena is a very important. Many times there is a packaging inside packaging choking happening, and then your efficiency will go down. So cleaning also very important. Scaling and deposition happen in here depend on the your input quality as well as media. So proper cleaning, proper monitoring of the particularly uh, scrubber efficiency is important here. Yeah, next. So Venturi here, see the there is a depend on the pressure and that Venturi shape benefit. Your mixing is a very proper here by your inlet gases and particularly media. That's why in compact situation we are utilizing Venturi scrubber many places. Yeah, next. So this is already we have discussed the techniques for VOC control as well as control mechanism like yeah, for particulate matter, yeah, particularly dry scrubbers. We already discussed on the above. Yeah, this is a summary for that. Yeah, next. If you see this sector-wise norms for, if you go through the that CPCB Green Book now, you'll get sector-wise norms. So they have decided almost all sectors norms. I have taken here pesticide sector norms as well as comparison with other. If you have SCLC, so other sector also same, 20. Chlorine, 5 for pesticide sector, 9 for other sector. H2S, 5 for pesticide sector, 45 for other sector. P2O5 for pesticide sector is compulsory, but other sector depend on the generation of the P2O5. If you see the ammonia, 30 for pesticide sector, 175 for other sector. PM with pesticide compound is a 20 in pesticide sector, like the products going out, solid products. So PM is a 20. And other sector 150 to 800. If you see the other sector like pharma, dyes specialty 150. And if you see the cement industry is 800. Methyl chloride generated in pesticide is a 20. Other sector depend on the generation. SBR here is 5. Other sector depend on the generation. Yeah, next. So right now is a there is a requirement. If you see this 2018 guideline and GPCB 2014 guideline for solid fuel, depend on the guideline you have to install particularly OCMS, online continuous emission monitoring system. That is a continuously on-time monitoring system that connected to the State Pollution Control Board website as well as Central Pollution Control Board website, and they are monitoring on the continuous base and automation. We are getting alerts if you are higher than the permissible limit. So this is a good initiative taken by Central Pollution Control Board, and lot of improvement happen in the particularly flue gas emissions like boilers running on the coal. So there is a need of particularly online monitoring system. Depend on your sector wise, they are given which parameter should be connected. So you can refer 2018 guideline, CPCB guideline. They have mentioned the farmers which parameters should be connected to the OCMS and CPCB and GPCB portals. Yeah, next. So we'll see third part is a very important like water, effluent and air. Like same is a hazardous waste management also very important in chemical industry. Yeah, next. So hazardous waste is that dangerous to potential harmful or health or environment because this is a concentrated lot of product impurities coming in the particularly hazard, because this is a purification state generated, uh, and same of the product purification. Some part of the products, some part of the raw material, some part of the solvents coming in that. That's why this is a very very dangerous than the effluent. It may cause increase in mortality, several illness due to the dumping of the hazardous waste unnecessary location. So very very important part: collection, storage, treatment, and disposal. Yeah, next. But you can do lot of improvements in hazardous waste management by this particularly pyramid. Most preferable is avoid and reduce the waste. This is happening during processing of your manufacturing products. So if you are really there is no conversion properly, your R&D process team, technology team to be work on that, how to convert your raw material into the product by 100% by some mechanism, some continuous to batch to continuous process, some catalytic introduction. So this is a very very important to reduce your generation of the waste and increase the productivity by increasing yield improvement. Reuse waste, if you are really generate, how to waste that reuse in some other place or same process, that is also recycle waste. This is also important. You generated your some byproduct, yeah, some solvent. Again, how the recycle that, that is also important. Then recovery. If you are generate 100 kg in process, again you can. Is it possible to recover some from that, or can be converted into energy? Co-processing is a good example for particularly recovery of energy. Treat waste and dispose is the last. Uh, if you are not possible above all these things, then properly disposal and treatment is a very very important part. Yeah, this is but only last preferable then. Yeah, next. So I have by experience I have written here. This is approach for environmental management. I have taken like from biological treatment to the up to hazardous waste generation, and I have find out some truth like if your waste is passing from ETP to incineration side, then your carbon footprint is increasing as well as cost also increasing. I will tell some approximately cost for ETP is maybe 300 rupees per K. Reverse osmosis maybe 500 to 600. Multiple effective per required about 1,000 rupees to 2,000 rupees per K. Chemical treatment already we have discussed 6 to 7,000 rupees per K, and incineration required 40,000 to 60,000. So that much proportionality also carbon footprint increase, because the incinerator required lot of fuel. So once the fuel utilized, carbon footprint is increasing. In chemical treatment, require lot of chemicals. That's why there is a carbon footprint is a higher. So whenever you are working in the chemical industry, try to take many trial research and all things, how this incineration and chemical treatment particularly reduce the effluent at source, or you can divert into the ETP and by doing some experimental treatment possible into it. We have done a lot of work in that, and we have succeeded in the particularly incinerable waste chemical treatment treatment into the ETP plant. ETP plant is a God gifted technology given by God, because bacteria is only working, that is a God gifted. That's why there is a lower cost in always in ETP plant. So try how your other effluent will be the treated into ETP or STP. Yeah, next. So generally waste other chemical industries same, like only here if you see the 29.1, 2, 3 and 5 that is a separate category for the pesticide sector. So 29.1 is a for particularly process residue, correct? 29.1 distillation residues, correct? 29.3 is there is a off specified product, spent solvent generated from 29.4 from pesticide, and 29 spent catalyst for. So they are bifurcated pesticide sector, particularly category. Other common for pesticide as well as other chemical industry. Yeah, next. And there is a disposal methodology. Category wise, there is a disposal methodology also there. So here also by experience we have written here. If you are toxic effluent generated from pesticide or other sector toxic, then incineration is the only one. If high calorific value residues and chlorine less, then co-processing to cement industry. If organic, very high organic, not possible toxic, then solid waste. Sometimes chlorine is higher, sulfur is higher, then incineration required. ETB sludge landfill. If ETB sludge having low chloride and calcium sulfate more, then you can give to cement industry. Used oil, cement solvent, lead batteries, you can send to the recyclers. Fly ash, you can send to the brick manufacturer, road preparation. Mixed weights you can send to the co-processing because they are plastic, plastic, wooden, and rubber, all these things. So there may be some good calorifically that can be utilized. Chemical gypsum to cement industries. Spent catalyst you can send to the recycler because there's some metal, some value there that should be recycled. Yeah, next. So environment is a common area, and whenever there is a common area, common place, and if you want to improvement, definitely there is a lot of pressure required, lot of people get together, gathering required. So that's why environment is a common area to all in particular all countries. So resolve this issue required some international agreement. So this type of international agreement happen depend on the issues happen, like ozone depleted in Antarctica at that time. Really, that Vienna Convention 1980 was published. That is for protection of the ozone layer. Then this is a really implementation. This Montreal Protocol 1989. So there is a evolution of the ozone depleting substance, that six compound, and they have control mechanism. When should be that compound should be phased out. That all this happen in the Montreal Protocol 1989. Kyoto Protocol 2005. There is a depend that issue the climate change. Then that the greenhouse gases evaluated like CO2, CH4, N2O, HFC, PFCs, and SF6 as the greenhouse gases. So there is a how to control into the atmosphere. That was the Kyoto Protocol to discuss around that part. Then Paris Agreement is a really implementation part for particular where about 180 countries have signed that. So how to control that average rise temperature 2 degrees centigrade and 1.5 degrees centigrade. That was the discussion, and there is a condition to all countries. One more waste management because lot of there is a waste generation during chemical industry manufacturing, and the waste is dumping to the developed country to developing country. So lot of health issues. That's why there is a Basel Convention 1992 to control the mechanism. So need two countries permission, two pollution control board, environmental agencies permission. Then only you can do that. There is one more convention, persistent organic pollutants. You may be heard about DDT and drill and all these things, pesticide of some persistent organic pollutants like PCBs also, polychlorinated biphenyls. So that 12 chemicals having half-life is a more. Half-life means that compound degradation up to half. required some period that's called half-life. So there is a very, very high, like maybe 500 year, 400 year, like this. And that compound is circulating from soil, water, human, animals, food, and all these things. And they're affecting to the human health and other part also. That's why they banned 12 pesticides, 9 pesticide and 3 PCBs. So that is called persistent organic pollutants. Now that when you cannot get enril nitro, you're not seen also. One more mineral convention that is for mercury based compounds and mercury in the effluent. So they are discussed. A lot of mercury is dangerous to health. So one incident happened in Japan. The one in the chemical industry disposing the mercury based effluent to the particularly river, and that fish was taking that as a food, and then human also taken as that fish. So mercury related issues happen in human as well as particularly that area flora and fauna. So that's why there are a lot of discussion on how to reduce mercury utilization. That's why many cases there is a ban also. If I see this caustic chlorine, maybe before this Minamitas convention, there is a caustic chlorine plant. There is mercury based membrane was there. Right now they are replaced banned that particularly. Right now there is a different membranes for caustic chlorine manufacturing. Yeah, next. So this is a organogram for particularly India, central government of Ministry of Environment and Forest Climate Change. Under that there is a department of a lot of department in ministry, correct? And Central Pollution Control Board, and there is a regional office of division office in about maybe 25, 26 regional offices. Like Baroda is the one divisional office for particularly CPCB. Pune also there, even though Bhopal. Like this, there is a 26 Central Pollution Control regional office there. Then state level, there is a state ministry, Ministry and Forest. Under that, Department of State Forest and Environment. Under that, the State Pollution Control Board, and there is a regional offices also there. This is a organogram for environmental management in India. Yeah, next. So I have taken here major environmental acts, rules in India. In 1970, there is a one international meeting. That time, Indira Gandhi has attended that meeting, and there is a discussion on that key how to control the pollution in each country. So first act we have published 1974 Water Act. Then after that 1981 Air Act. But in between there is a 1984 one incident happened in Bhopal. So there is no sufficient control mechanism legally because that incident happened in the process part. Their ATB parameter was very, very well within the limit. Process tax also very, very well. Ambient air also very, very in the limit. So how to punish that company was the question. So 1986 published. So right now this act is called Umbrella Act. If anything happen from gate to other boundary, they can punish under this. Many rules under this, maybe 30, 35 rules under this, like hazardous waste rule, biomedical waste rule, then e-waste rule, debris rule, many rules, noise notification, all these things they can punish under this. One more, there was an issue during this Bhopal incident, how to give the many there is a losses miss, and even though property losses and death also there. So who should be paid to them? That was the question with the government. So right now that problem is resolved. They are collecting EMI form depend on the capital investment of the company that collected money utilized during the incident as well as after the incident also. One more act, National Green Tribunal Act in 2010, because lot of there is a awareness in public, so they are putting cases into local court as well as the Supreme Court, High Court, but there is no attendance due to the other cases, criminal cases, human cases. So there is a separate uh, court issued, and right now any environmental related cases they are handling in that court, NGT court. Yeah, and other important rule is a hazardous waste rule 2016 is a very important for chemical industry. Yeah, next. So already we have discussed here. All this thing list is there under 1986. If you see this major rule we have published, only in pesticide sector need Insecticide Act 1968. If you have go to CIB website, Central Insecticide Board, lot of information available on that website related to pesticide. Otherwise, this all acts will get you will get in the MOF site as well as CPCB site or GPCB site also. This all environmental related. Only insecticide is a separate requirement for pesticide sector. Yeah, next. So in any chemical industry or pesticide industry required monitoring like effluent, inlet, outlet, stage wise, soil monitoring, hazardous waste monitoring. Some requires monthly patraks, annual hazardous waste return form 4, environmental statement form 5. All these things is a requirement to run the chemical industry. So yeah, next. Many new requirement given to state pollution control board or central pollution control board, like display board required. Yeah, display your the information on the waste side. Sector wise norms also we already seen. Water harvesting system required. Green belt development 30% inside, or sometimes they are allowing online monitoring system OCMS also required. Byproduct sales under hazardous waste. Rule number 9 SOP is required. Job work outside required lot of permissions and all these things. FETP, there is other requirement from the FETP, CETP as well as association. Your association also there is some requirement. In Gujarat, environmental audit also. In Maharashtra also, last 3 months back there is a requirement of this and OCMS. Yeah, next. So this is also one new requirement ISO 14000 responsible core MIF CPCB online regular updating. They are updating many rules and regulations. GPCB asking sometimes SAP data, stormwater drain, pH meter, CCTV camera, order control that is requirement. Storage area for RM, FG and all these things separate. ZLD required, but sometimes solvent recovery above 95%. LDR required, leak detection and repair system. GPS system for hazardous waste vehicles, CCTV, the camera at gate, CR activity, always proper records and inventory. Yeah, next. This is a requirement to chemical industry. So this is a mandatory requirement to your record. ETP log sheet required. Yeah, any environmental management systems equipment required log sheets. Hourly basis you have to monitor. Hazardous waste generation and disposal. Form number 3. Production water consumption effluent generation data always need. Green belt development area. Air monitoring records also required. Scrubber required. Cold records. All these things records also very important to particularly record for internally, and they are verifying also. Yeah, next. So EI is also very important part for environmental clearance. I will not take much time because There is a two, as per 2006 notification, there is a two category. One is a category and B category. So aim is more big industries and more environmental impact industry like petrochemical, cement, and pesticides. That is comes under A category. B category is slightly less, so they are segregated into category. So expert appraisal committee take care of A category, and state appraisal committee is taking the care of the B category. So there is a screening, scoping, and all these things. Public consultation. That is a sequence for particularly, and preparation of final year depend on the your TOR conditions, and appraisal presentation required, and then they give the environmental clearance. That is a procedure for particularly EC notification 2006 and amended time to time. Yeah, next. So this is a procedure, same procedure, and required standard time. This is given by Ministry of Environment and Forest. Sometimes they are taking much time because there is a ADS and EDS generation, additional detail required requirement. On that basis, slightly taking more time. Yeah, next. This video can run possible. There is one video, small video, 1 minute video, if possible. Otherwise, okay.
Yes, yes, possible.
Okay, maybe slightly difficult to run, but this small video, it will get a good message. Okay, thank you.
Okay. Any questions from participant, please, or drop any questions on chat box also. You can write your questions on chat box.
Otherwise, you can write my mobile. If anything in your mind, you can connect to me also. My contact number is 990 999
Yes.
4207.
990 999 4207.
4207. Yeah, yeah. Thank you, friends. Uh,
Okay, I think so. No questions from participants. Okay. So, thank you very much, sir, for your informative session with us, for providing a very important information about water pollutions, air pollution from the pesticide industries and other sectors, and give information about the treatment, advanced treatment processes for the water, air pollutions, as well as hazardous managements, and how to protect the environment also. So these are the very informative sessions for our participants and us. The participant, it will be benefit from these sessions. So, and thank you very much for sir, for accepting our invitations and providing us your time from your busy schedule. So thank you very much, sir. And
Thank you.
all participant, we have to take one photograph. So please keep camera on. Please wait 1 minute. Participant, please put on camera on. We will take one group photo with our expert. Mitesh, it is done. Okay. Participant, please put your camera on. Switch on your cameras, please. Then we can take one group photograph. Okay, done. Okay. Okay, sir. Thank you, so. Thank you very much, sir, for giving this such
Thank
time
you
to
all.
us. Okay.
Good night.
Welcome, sir. Good
Good
night.
night.
Very good night, sir. Dear participant, tomorrow session will sharply start at sharp 6 p.m. So please stay online. And I have already shared a link, attendance link for session 5 and 6. Now I will share feedback form. So feedback form.